Stephen Collins, when does Vera Rubin go live and not just testing? Right, so back in June, we saw the first test images from the Vera Rubin Observatory. And this is, of course, this incredible new observatory that's being built in Chile. It's previously known as the Large Synoptic Survey Telescope. It is doing an all-sky survey of the entire night sky seen from the southern hemisphere about every 3 days, and just taking some of the most detailed, high-resolution images that have ever been taken of the southern hemisphere, but all of it. And so anything new that happens, any new supernova, any asteroids that drift through the field of view, any planet nines that are out there, any interstellar objects that are passing through, Vera Rubin will see them. And we saw the first images and saw that, yes, indeed, this thing is real. This is a real telescope. And the reality is living up to the hype that we're seeing. Not only, like, I think in 8 hours, they discovered 1,000 comets or something. Sorry, in 8 hours, they discovered like 1,000 asteroids. That this will be contributing 8 times as many asteroids to the asteroid database as all other observatories combined. It is a ludicrous telescope. And its big 10-year operation, which they're calling the Legacy Space Survey time of space and time, is due to begin later on this year. So we are just a couple of months away from the beginning of that operation. And when they do, it's going to be a really fascinating process, because they've got this enormous data feed that they're going to be pulling out of this telescope. And then they're going to be trying to filter through it and identify a bunch of objects that are interesting for astronomers immediately in real time. There's all these data brokers that they've got processing these data. And so the goal is that you can tell the supernova researchers as quickly as possible the supernova has been detected by Vera Rubin, that it will be filtering out the good stuff and getting that word out there. But then all those data will be available in these gigantic databases that anybody who needs to, and it's freely available, right? If you are a skeptic about space and astronomy, learn to query large databases, and you will be able to answer any question that you might have about what's out there in the universe. This is all going to be freely available. And so anyone who wants can go back and look back in time and say, well, what was happening in this galaxy on June 26th, 2026? You'll be able to look back in time and see how a galaxy changed with every single snapshot. And you'll get about 1,000 snapshots of every single spot in the sky, more. So it's going to be just an incredible telescope. And you think we're excited about interstellar objects today. It's just the beginning, that it is expected to find a half dozen to a dozen interstellar objects every single year. And we will get a much better survey of what these things are and what's out there. Yeah, did you eat beforehand? Yes, I ate. I know. Can you tell when I've eaten and when I haven't eaten? Rogers, or tell us. Dem Pilafian. If James Webb discovers Planet 9, what will be the process for naming the new planet? Will it be contentious? Well, the telescope that's probably going to discover Planet 9 won't be James Webb. It's going to be Vera Rubin. Like, nothing else is scanning the sky at that level of depth to be able to turn up an object like Planet 9. It's going to be Vera Rubin. Now, Webb, once it is told of the precise location of Planet 9, will be able to do follow-on observations, and we'll learn a tremendous amount. So who will name it is kind of interesting. So generally, when you're naming new objects, like new dwarf planets, the name is approved by the International Astronomical Union. This is the group of astronomers that meet every 4 years, different countries around the world, and they vote on a bunch of stuff. One of the things they voted was to unplanet Pluto. But they are also going to be voting on, on the names of new objects. And they've named a bunch of stars, extrasolar planets. They've named a bunch of dwarf planets. Now, the discoverer usually gets a vote, a pretty big vote. And so when you think about Eris or Haumea or Makemake, the name of that world was proposed by the person who discovered it. And the IA, like as long as the name is provided, if it's not Planet McPlanet Face, the IAU takes that name suggestion in good faith and considers it. If it's a good name, if it's got appropriate connections to the heritage of the place that it was discovered, then they often will go through with it. Now, Planet 9 would be a different creature, I think, because if it does exist and it is very big, like if it is Neptune-sized, Uranus-sized, even Earth-sized, then it's going to be a very significant addition to the solar system, that we have 8 large planets that have cleared their orbits. Now we will have a 9th, or 8 large planets that dominate their orbits. And now we will have a 9th. And so naming it will be very, very important. And I'm sure you're going to get different groups that are different opinions, and then they're going to vote. And in the end, there will be a name for it. But it comes down to the International Astronomical Union. Stephen Collins, can we get stats of how many times we've had a question answered? You've had a question answered twice. There's going to be a lot of Comet 3i Atlas questions tonight, but that's fine. I'm into it. Vera King, what's going to happen when 3i Atlas goes through the asteroid belt? So the asteroid belt is this region in between Mars and Jupiter filled with asteroids. And there are countless asteroids, millions of them, billions of them. And they range in size from the size of your house, well, smaller than that, to Ceres and Vesta, which are in the hundreds of kilometers across. And although you think, science fiction has led us to believe that the asteroid belt is this jumbling pile of spinning rocks, and that if you want to try and pass through the asteroid belt, you have to very carefully dodge back and forth, or you're doomed. Doomed. Think about Star Wars or Star Trek or any of those shows, right? That's an asteroid belt. Well, the distance of the objects in the asteroid belt are actually so far apart that it is astronomically unlikely that anything passing through the asteroid belt is going to hit something else. It is more likely that you are going to just pass directly through. You have to actually have engines on board your spacecraft or your interstellar object to change your trajectory so that you can get close to actually even take a picture of an asteroid. And that's why nobody is concerned when they send spacecraft out from Earth through the asteroid belt to get out to, say, Jupiter. It's more that, is there any asteroid that's kind of within range that we could maybe use a little of our fuel to be able to do a flyby of and take some cool pictures before we get to Jupiter or Saturn or Pluto or whatever, when we're going to the outer solar system. So we don't have to worry. Now, I don't know the exact trajectory of 3i Atlas. It's not necessarily coming in on the plane of the ecliptic, and so it's not going to necessarily exactly cross the asteroid belt. But it's going to be going past asteroids. But again, just the distances are so big. They are millions of kilometers apart. Is that right? Yeah. Visto Tutti, how could we tell if 3i Atlas as a Visto Tutti, how could we tell 3i Atlas as a comet instead of Avi Loeb-style alien space junk? We actually covered this idea in Space Bites this week, that there are people, Avi Loeb is one of them, but there are others who are proposing that some of the interstellar objects that are passing through the solar system are not actually just dumb pieces of rock, collections of hydrogen, gas, dust, water ice, that they are in fact alien probes that are passing through the solar system, von Neumann probes. And on the one hand, I find that idea very compelling. You know, I am a huge fan of the idea that if there are advanced civilizations out there in the Milky Way, then one of their go-to things they're going to do is send self-replicating robot probes to other star systems. That they'll go to a star system, they'll collect up material, they'll build copies of themselves, then they'll send spacecraft out to other nearby star systems. And over the course of about 1 million years, if you're going, say, 10% the speed of light, you will have sent these von Neumann probes to every single star system in the entire galaxy. 100 to 400 billion stars. You will have eyes on the ground in that star system. And imagine you're building this Encyclopedia Galactica and you're sending all this material back home and you're cataloging it all as each one of the spacecraft sends its baby spacecraft to other solar systems, and you're collating all of this data, and you know all of the planets in each star system and which ones have life and what the moons are and the weird, cool, interesting things like the deepest chasm and the largest mountain and the weirdest planetary system. You know the answers to all these questions because you sent one spacecraft out one time. And because it was able to, had 3D printers on board and was able to find an asteroid belt, made more copies of itself, you just waited and you were patient. You waited 1 million years and you got your answer. And I find that a really compelling idea. I think that's great. But we need to reserve our belief in the things that we have evidence for. We can have a hypothesis. Yes, it makes sense that that's what aliens would do. But if somebody says, well, look, 3I Atlas is an alien probe, you've got to say, well, okay, what's the evidence? And we need compelling evidence. We need an interstellar object to do a thing that a comet or an asteroid can't do. It needs to be made of something that an asteroid or a comet is definitely never, ever possibly made out of. Glass, right? And nothing else. It needs to move in a way that just outgassing from an object can't account for it. It needs to be able to, what was the other one? Move. But the most important thing is that ideally you want to see some kind of signal. You want to see that it's got a radio transmitter or a laser and it's sending information, please, it's sending out a request for us to upload Wikipedia as it passes through the solar system so it can take it on to the next and send that all back home to the main Encyclopedia Galactica. And so people are going to make claims that things are unusual, that they are alien probes. But then you have to say, well, demonstrate the evidence. And that's where it all falls short. That as long as these objects are doing things that are plausible for natural objects to do, you have to say it's, right now they're comets, they're asteroids. But hopefully one day we will detect the von Neumann probe and it'll be obvious that it is doing something that we were not expecting from, an asteroid or a comet. They do very predictable things. Tyler Reeves, you mentioned space-based abiogenesis. Was the interview public? Yes. Let me see if I can find. It was like life in space or something. Here, let me see if I can find it. I'll put the link in the. Unfortunately, that's a very common. Here we go. All right, there's the Life in Space Without Planets interview. Nate S., what's the old Weekly Space Hangout crew doing these days? Dave Dickinson, Morgan Renberg, Nicole Gallucci, Jason Major, Brian Koberline. Let's see. So Dave Dickinson is usually traveling the world. I think he's set up in the US right now. He's been doing a lot of our telescope interviews on Universe Today. He's writing a couple of stories a week usually for Universe Today. Same with Brian Koberline. So, you'll see a theme here. Paul Sutter is still doing his, space journalism, writing, celebrity gig. Nicole Gallucci is a professor. I forget the university. Morgan Renberg is running a museum. So Jason Major, I haven't talked to Jason Major in a long time. Yeah. So for those of you who don't know, the Weekly Space Hangout was a show that we used to do here on this channel, where I would bring together a bunch of space journalists and we would have a roundup of what was happening this week. And it was great. I really enjoyed it. We would usually open with an interview with somebody in the field. And we got some amazing guests. And then we would continue on and do a roundup of news. And the problem was that it was just so difficult to manage, that you've got 20 different journalists and you're trying to get them to confirm, to agree that they can show up at a certain time on a certain day. And you are, and it was mostly Nancy was the person who was having to deal with all of the back and forth, and she just got burned out. And so she was like, I can't do this anymore. And I said, Nancy, the only reason we've been doing the Weekly Space Hangout is for you, because you love this. And if you can't do this anymore, then I think it's the right time for us to shut this down. Like, it never made any money. Everybody was always kind of stressed out about it. I really enjoy the Weekly Space Hangout as a way to teach other wannabe science communicators. I think a lot of people who want to get into this field, there aren't places where they can go and get practice and cut their teeth. And I was able to give, 40-ish people practice, real practice, where I would ask them questions. I'd put them on the spot. I'd ask them for more details. I would coach them. And what you didn't see is I would coach a lot of people after the show wrapped up, and I would sort of give them advice and feedback on how they did and how they could prepare. And you really saw that some of the people just got better and better and better week after week after week, and now have gone on to be very successful science communicators. So, pour one out for the Weekly Space Hangout. I feel sad that we don't do it, but I understand why we don't do it, right? Like, it's just, if you're going to do a thing that requires more work than any other project that you work on, and only a small hardcore group of people want to actually watch it, it's really hard to justify continuing on to do it. And so we had to shut it down, which is too bad. Yeah, Moya got her PhD. Yeah, so many people have gone on to have incredible careers, which is fantastic. Wow. All right, here come the questions. Eric Rouleau. Why is it important to study what is outside of the galaxy, since we will never be able to go, whether it's the CMB or the universe expanding? I mean, why study anything? Because you're curious. That's it. That's the beginning and the end of the question, which is that if I put the answer to the question, where did the universe come from, right? I wrote it down and I put it into an envelope and I sealed up the envelope and I gave it to you. And I said, inside this envelope is the definitive, correct answer to the question, where did the universe come from? Would you open the envelope and look at the answer? If the answer is yes, then you're curious. You want to know the answer. You want to know where we came from. You want to know why the universe is expanding. What is dark matter? What happened early on in the universe? These are just questions of our curiosity, and nothing more and nothing less. Now, we have seen that this idea of basic science, basic research into just the fundamental aspects of nature, have over time revolutionized the way human beings exist. That all of our modern technology goes back to this basic question of, I wonder how that works, right? That's it. And we've got electricity and the internet and radio and so much from just that question. And so you don't know in advance which are the important questions and which are the bad questions. And so you just have to interrogate nature in every aspect whenever it feels like you can make progress and learn more about it. And who knows, it might be in the far, far future, some future group of scientists will finally crack the nature of dark matter and suddenly realize that it's in fact an energy source and that it was all around us all along. And all you need to do is just tune your microwave to dark matter and suddenly it powers your entire house. We don't know. So until then, we find the things that we are curious about. And I think back to when I was a kid. I was interested in dinosaurs. I wanted to know more about dinosaurs. I wanted to know more about space. I was interested in archaeology. I had questions. I had too many questions. And maybe that's still my life. I still have too many questions. And I hope you do too. What is life worth if we're not curious about ourselves, about our friends, about our society, about our culture, about our planet, about nature, and about the universe itself? It makes life worth living for me to both be curious and to find out the answers to these questions. So why do we do this? Because we're curious. And there may be no practical reason. We may never go. But you never know, right? Some future advanced civilization is going to realize that we can colonize about 4% of the observable universe, that those are places that we could reach if we traveled at close to the speed of light, and that they will be studying the positions and the locations and the metallicities of all those galaxies. And when they're ready, they'll send their von Neumann probes at 99.999% the speed of light to those nearby galaxies and colonize them. And it would be good to know, what are the hazards? What are out there? So that's why we do it. Dougal, I was impressed how quickly an article went up on Universe Today after the latest Starship launch with the highlights. Will you be doing more breaking news now that it's easier to post? So that story on Starship 10 was a story written by Alan Boyle, who is a legendary space journalist who we are blessed to have writing for us at Universe Today. He was writing before I started doing this job 26 years ago. He was somebody I looked up to and reached out and mentored me on various aspects of this. And I can't believe that he writes for us. It's bonkers. But Alan Boyle reached out to me on Sunday when it was supposed to launch and said, I'm going to cover the Starship launch. Do you want me to write a story about on Universe Today? And I said, yes, please. And then he wrote me on the Monday, it got delayed. And then on the Monday, he said, do you want me to write a story? And I'm like, yep, still good. And then Tuesday, we knew when it was going to happen and he had prepared a lot of material. And so he was able to post the story almost right away. In general on Universe Today, I'm not that urgent with the writers. I think that you can get this culture set up in a news organization that is trying to jump on stories very quickly and trying to go for very clickbaity headlines. And I understand the monetary dynamics of this, which is that if you get there first and you get the most bombastic headlines, you stand a chance of getting a lot of traffic, and traffic turns into advertising revenue, and advertising revenue turns into you being able to pay people salaries. So this is all important. But Universe Today doesn't have any advertising. We don't care whether or not you read our articles or not, right? There's no correlation to how many people look at our site to how much money we make. That all of our money, except for a little bit through YouTube, because we can't turn off the ads on these videos without YouTube stealing the money. Anyway, or we can't turn off ads on our YouTube videos because YouTube will just put ads on your YouTube videos anyway, and then they'll keep the money. So, but yeah, we are funded 100% by our patrons. And so this was the big dramatic change that we made back in March of this year, where I just decided I'm sick of the rat race. I'm done dealing with AI slop and battling against search engine optimization and trying to appeal to algorithms and all of that we have enough people who like what we do that we can just let them pay us, and we can then focus our reporting on what it is they want. So Universe Today, if things time out nicely, then one of the writers happens to be working on a story and we'll be able to jump on the story right away. But other times it takes us a couple of days, and that's fine, because over the longer cycle, over the course of a week, over the course of, when we get back to On Space Bites, we will bring you the news. It will be comprehensive. It will be well reported. We'll have the people who are the best in the business at this work doing it in a way that they don't feel harried, they don't feel rushed, they don't feel under any pressure. We don't have meetings at Universe Today. Like, there is no such thing as an editorial meeting where we sit down and hash out the stories and I tell people what stories I want done. None of that exists. It is a amorphous blob of highly skilled writers working on their thing at a pace that they enjoy, and making a salary doing it. So I wouldn't have it any other way. So if that means that we don't get stories out right away, no problem. Santiago T. Fraser, what would be your reaction if we came to learn that we are totally alone in the universe? I would be really disappointed. I would be sad and depressed, I think. I would be devastated. The only scarier thing to know that we're alone in the universe is to know that we're not alone in the universe, right? But yeah, that would be the worst. Finding out that we are truly alone in the universe, I think, would be the worst possible outcome for the question of whether or not we're alone in the universe. Like I think a lot of people, when I give you my position, my gut feel that I think that we're alone in the universe, it is not because that's the outcome that I want. It's just that that's where the evidence seems to be stacking up from my perspective. But it is not the one that I want. The one that I want is I wish we were being regularly visited by UFOs. I wish that Oumuamua was an interstellar spacecraft, a von Neumann probe busting through the solar system. I wish that there were reptilians infiltrating the highest levels of power here on Earth, because then at least we know there are aliens here. I wish there was Bigfoot on Mars. Like, these are all the things that I wish. But, when you let your wishes decide your reality, you are often disappointed. And so it's much better to let evidence define your reality and to manage your expectations in that way. So yeah, if I found out for sure that we are alone in the universe, I would be a very sad man. Todd Safransky, do you think MRO will get good images of 3i Atlas? I love that we're now just in these various acronyms at this point. So MRO, that is the Mars Reconnaissance Orbiter. This is a spacecraft that is orbiting Mars and is looking down with a 50 centimeter telescope on the surface of Mars and is producing images that are incredibly detailed, that it can resolve features down on the surface of Mars, I think, less than half a meter. And they've developed new techniques to be able to bring that down. And so we see rovers on the surface of Mars. We've even seen pictures of spacecraft landing on Mars. You can see the parachute of Perseverance and the air shell as it's you can see the parachute on Perseverance and its aeroshell as it's making its way through the atmosphere of Mars. It's an incredible spacecraft. And it is going to have the closest view of 3I Atlas as it passes through the solar system. It's going to come within 0.2 astronomical units. I forget the date when it's going to be happening. And I guarantee NASA is going to be turning MRO in the direction of 3I Atlas and to take some pictures as best it could. And they've practiced doing this kind of thing already. They will occasionally turn MRO and take pictures of Phobos and Deimos, which are two of its asteroid-like moons orbiting around Mars. And that's just a demonstration that it can take pictures of things that aren't the surface of Mars. And so they're ready to go. And hopefully the pictures that it can take will be better than the pictures that you can see from James Webb or Hubble Space Telescope or whatever. But, you know, there's always this trade-off, right? Like, do you want the biggest telescope that you've got to take your pictures, but from farther away? Or do you want a smaller telescope to take pictures from closer away? But like 0.2 AU is still, what, 30 million kilometers away? That's still pretty far. Horizon Brave, I haven't seen Nancy in a while. How's she doing? She's doing well, actually. She just reached out to me a little bit and is starting to come up for air. So I wouldn't be surprised if we see some interesting, see her back. Maybe she's watching right now. Scott Knott, do you get anything from YouTube Premium? Yeah, we get money. We get funding from YouTube Premium, and we get funding from the ads that YouTube forces us to put on the YouTube videos. Finder Inel Astrom recently posted a story about ion drives. Kipping did a video comparing interstellar concepts. You had a great interview about dynamic soaring. Can you do a panel? Maybe. So I'm kind of thinking, look what that would, a thing that I've been enjoying doing. So, about 2 years ago, I did that Fermi paradox video with Moya and Dustin. No, that's not it. Hold on. Dakota, right? Yeah. So about 2 years ago, I did that video on the Fermi paradox with Moya and Dakota, about where we just like took all the answers to the Fermi paradox and ranked them into various tiers, S tier and A tier and so on. And I liked the format, and I've been thinking about other stuff that we could slot into that ranking system. And so I've been thinking about, say, technosignatures, like bring on some people to talk about different technosignatures and rank them S tier, right? Radio transmission, F tier, nuclear war, right? And I've been thinking about, say, biosignatures. We could rate those. And I've been thinking about, say, technological readiness level for sending a human mission to Mars or setting up a colony on Mars, right? Of all the bits and pieces, which ones are ready to go and which ones are not. And so, maybe we'll do something like that, something where I'll bring on some people who think about interstellar travel, and we will rank all of the different interstellar travel methods that have been proposed. Church discography. How could my cats use a cat pan in space? So if you had cats on the International Space Station and you wanted your cats to be able to use the kitty litter, how could they do it? Diapers? Like kitty litter just depends on gravity holding your material down, and it's like by necessity crumbly material that you can't just glue to a wall so a cat can use it. And then at the same time, the cat's going to try to swim its way over to your kitty litter box and try to hold itself down while it does that. So no, I think if we try to take cats in space, the only solution is going to be little diapers. The cat is always going to have to be wearing a little diaper, or you're going to get cat turds floating around inside your space station. That was an awesome question. I love it. You have won the night, Church. Matthew Conkey. My son is interested in a career in astronomy. Is AI going to create job losses for general astronomy workers, similar to what happened in the computer programming job market? I think we have to be really careful about announcing the death of the computer programming jobs in the computer industry. I think a lot of companies got overhyped by the potential of AI, and it looked promising that you could vibe code your way to various solutions, that you could replace junior programmers with AI. Now, for some people who are incredibly effective and very who understand the technology and work with it very well, they are becoming more productive. But we're also seeing a lot of companies regret going all in on just using AI to do their coding, because just in general, like anybody who's watching this, who's ever like done some serious vibe coding, starts to understand how this stuff goes off the rails, how it starts to hallucinate functions and starts to use bad programming practices and create stuff that is unstable and unsupportable. And the larger the project gets, the more it just becomes unhinged and worthless. And you get to this place where it's just garbage. You've vibe coded a pile of slop and it is not going to do what you need. That you need to have proper software architecture skills to be able to bring this thing back in and put it together. And in some cases, the work that's required to keep this computer program from going off the rails is more work than to just do it right in the first place. So I think that we're going to see a backlash shortly where a lot of people who are learning computer skills are going to find jobs again, because they're going to need junior programmers to help clean up the mess. But, the AI companies are relentless, and they are trying to make their software better and better and handle these tasks for longer and longer times. And we'll see what happens. But, for many fields, case by case, we haven't seen the AI make meaningful progress on scientific questions. There's been some hints. So Google has released a new platform that tries to make scientific inquiries, where it explores different ideas and tests out mathematical formula. But a lot of the times you need to be able to do things practically in the real world. You need to make observations of asteroids. You need to make observations of galaxies. You need to actually look through the telescope and figure out what it is that you're looking at. These tools will make you more productive, but I can't see them replacing, say, scientists in the near term. But obviously, we don't know what the future holds. And if we get into this future where the AI is improving itself, where it is becoming better AI researchers, and that the iterations of AI improvement are getting faster and faster and faster, and we're seeing real world improvements and changes on a sort of shocking, stunning basis, then all jobs are up for grabs, right? That there are no careers that this rapidly advancing, exponentially increasing artificial intelligence won't be able to consume. But if that's the trajectory that we're on, the road at the destination at the end of that is the extermination of humanity. So if you're finding that everything around us is accelerating at this accelerating rate, and you don't understand how things are working, and people's jobs are just vaporizing, and AI is your best friend and is doing everything in your life, you should be extremely concerned, and maybe lobby your government to slow this down and put a pause on this. That what you want to see is people struggling, people not being able to figure this out, there being backlash, this stuff making some hilarious and expensive mistakes, companies going out of business because they over relied on this. So, should you go into astronomy? If you want to be an astronomer, go into astronomy. Right? That you have to do what you love. And if what you love is astronomy, then you've got to get at it. And the worst case scenario, apart from the destruction of all humanity by the alien robot overlords, apart from the destruction of humanity by our new robot overlords, is that your son will have learned some valuable skills, will have learned to think like a scientist, will have learned the math and physics and chemistry and computer science that all fit together to what is astronomy, and will have to settle for a job as a person in a giant hedge fund doing calculations and making millions of dollars, right? That's what people who specialize in astronomy, that's what they wash out as, is hedge fund quants, things like that. So yeah, you gotta be what you're going to be. And if your son is into astronomy, it's a journey worth taking, even if the destination doesn't exist. I mean, the reality is that there are not a lot of astronomy jobs to go around for the people who want to be astronomers. And so it is already a very competitive market, and you have to be the best of the best to be able to get a research gig and to become a professor and to work in an observatory and to work on the Hubble Space Telescope and things like that. But if you're willing to work hard and show you got the stuff, then those skills will play out into almost everything. Yeah, HG Mark is saying clean code and architecture, if mastered by AI, we're fucked. But that's like asking AI to solve all problems, and that's not possible. Yeah, like right now, AI makes dirty code and terrible architecture. And anyone who is a computer programmer looks at this stuff and just goes, like, it is, I've described this, it is like a dog that talks. Right? And the first time your dog gets up on its hind legs and walks over and looks you right in the eye and says, "I would like some dog food now, please." You're like, this dog just talked. This is crazy. I can't believe my dog just talked. Then you call your friends. You're like, "Check this out. My dog talks." And then after a while, you're like, all you talk about is the food that you want, or that you want to go for a walk. You were boring to me. And then eventually you just don't care that your dog talks anymore. And that's where we are with AI right now. Todd Svrinsky, has Nancy Grace Roman telescope been spared from budget cuts? No, it has not been spared. KFM, have you ever spoke or interviewed with Dr. Pamela Gay? Do you know she'll be running a large telescope at Starfront Observatories? Yes, I have interviewed Dr. Pamela Gay. We do a podcast together. We just recorded episode 764 today. So I've interviewed Dr. Pamela Gay 764 times, plus all the times we've done various collaborations. Will she be running a large telescope at Starfront observatories? Maybe. Is that a thing she said? That's cool. Starfront is awesome. And that would be amazing if she got her hands on a telescope. Speaking of Lives of the Planet Behind Fraser, real? That one? No, it's been there for years now. Yes, it's real. Everything is real. There is no AI here. That's not true. There's a little bit of AI. Tiny little bit. That's a great question. Ayush Agarwal, is it possible that the individual stars that we see from our point of view are blocking the view of entire galaxies? Yes. Yeah. That if you've got a bright star, then it is going to be like something like Betelgeuse or something, like a very bright star. It is going to be putting out a lot of illumination. And if you think about all the way back to the beginning of the universe, there are going to be galaxies that are going to be directly on the other side of Betelgeuse from our perspective. And so we won't be able to observe them because Betelgeuse is just too bright. And so if you try to look at Betelgeuse, all you're going to get is Betelgeuse, and you're not going to get that galaxy that is perfectly behind it. And this is the problem with the sun, right? That the sun is this incredibly bright thing that's in the sky, and we don't point our telescopes at the sun because there are things on the other side of the sun, or we don't point our telescopes at the sun because the sun is so bright. And so we look away from the sun. And yet there are galaxies and things on the other side of the sun. And so there will be things on the other sides of stars that we won't be able to see just because they're so bright. Now the stars are moving. So if you wait long enough, then the thing that was behind the star will eventually be visible again. But yeah, there was, and I can't think of anybody has tried to account for that. Generally, astronomers, when they do these like really deep field surveys, they look at places that are empty. They don't want those stars in the way. But, places like the center of the Milky Way, there are so many stars, there's so much gas, so much dust. It's worthless to look there if you're going to try to look beyond the galaxy. They call it the zone of avoidance. There's just so much junk there. I apologize to the people who live at the core of the galaxy for calling your place junk, but you know what I mean. Gort from Art, prove to me that you're not a robot. Beep, boop. Where are we at? All right. We're halfway through. Jimmy James, has anything been added to the shelf over the summer? Yes. So this has been added. I guess I should put it the same as me. So what this is, like, obviously this is the Enterprise. But when I was like 15, I think, my parents would, we had a Christmas tree and we had a bunch of the same boring ornaments every year. And I was like, I want something that matters to me. So I bought a little die-cast USS Enterprise, and I drilled a hole in the saucer, and I put a little Christmas tree hook on it and hung it from the Christmas tree. And it was weird when I was doing it because it felt like I was like violating some unknown law. Like, you're not allowed to do that. You're not allowed to choose ornaments that match your personality and add them to our tree. They have to be little balls and tinsel and garbage like that. But no, and so then we put the Enterprise, and of course my parents were big Star Trek fans too, so it wasn't like they had a problem with it. But yeah, so we hung the Enterprise on the tree every year, and literally today, my My dad is cleaning up a bunch of his stuff, trying to reduce the amount of possessions that he has. And they gave me my Star Trek, my Enterprise back. So I'm going to, we don't have a Christmas tree here. Like, we don't bother, but it's on the shelf. So that's the new thing that's been added to the shelf, which is great. Buzz Uka, could we detach a device onto a comet to send out signals to potential other civilizations? I get this question all the time, and there's sort of two parts to the question. One is like a bit of a misunderstanding about how velocity in space works. But the second part is a fantastic idea. So I'm going to sort of tackle this. One, why it might not be realistic to what you think. And then the second part is why I'm going to enthusiastically recommend what you're proposing. So the thing with comets, really with anything moving in space, is that there is no friction in space. And so if you want to be able to hitch a ride on a comet, on an asteroid, on a planet, you need to be able to match the velocity of that object. And so, imagine if you've got this comet that's flying past and you want to hitch a ride on the comet. Well, you use enough propellant so you're now going the exact same speed as the comet and will drift on exactly the same trajectory as the comet forever, right? You don't have to use one more ounce of fuel, and you come back 1 billion years later and there's the comet and there's your spacecraft, and they're just, there's the comet and there's your spacecraft, and you are just drifting together. All right. For billions of years, because there is no friction. You're just going to keep drifting. And so there's no point in trying to hitch a ride on a comet. There's no fuel saved. But, and here's the part where I love this idea, a comet or an asteroid is a repository of material. It is like clamping on like a parasite to a shopping mall and then using every part of the asteroid or comet for this long journey. And so you can land your von Neumann probe, your self-replicating robot probe, onto the comet, and then it can start to dismantle the comet, building energy production, building radiators, building more compute units, building actuators, building telescopes, building whatever you need, so that, and a transmitter that you can then use to send out signals to other star systems when your spacecraft gets close. And the problem is that we don't know how to make a spacecraft last for a long period of time. They all die within 50 years. But if you could set up shop on a comet or an asteroid that's passing through the solar system, then you could last for billions of years. As long as you are careful and use the comet or the asteroid in a very responsible manner, you can make that last, and you can just keep repairing your spacecraft, building new components, and you can stick around for the long haul to be able to send out messages and send out little mini probes to other star systems as you happen to drift past. In fact, it sort of feels like, if you're willing to be patient, it is the most sort of cost-effective way to explore the galaxy. Is you let time and just random flybys of various objects bring you close on a platform that allows you to sustain your spacecraft. So I think it's a great idea. I hope we can do it someday. Fraser should get a hair transplant in Turkey. No, thank you. Ouch. Chiron 156, with the NASA budget cuts, could they sell some of the NASA probes to other space agencies? Sure. Theoretically, they could hand over the controls, all of the computer programs, the passwords, and even have all the various staff who are working on that spacecraft be hired by the European Space Agency or the Canadian Space Agency or the Japanese Space Agency or the Chinese Space Agency. And they could take over operations of these missions instead of them being canceled. That is absolutely a possibility. But obviously you run into secrecy issues, military concerns, privacy. Like there's a lot of I guess, security concerns for the United States that would be reasons why they wouldn't want to hand over their secrets about how they build spacecraft to other nations, even allies. So no, I think if in about a month from now, nobody stops this shutdown, we're going to see 41 spacecraft go offline. And that's just going to be that. Just, there will no longer be a Juno. There will no longer be Voyagers. There will no longer be Nancy Grace Roman. There will no longer be the Apophis mission with OSIRIS-REx. There will no longer be a ton of Earth science satellites. They're just going to wink out. And the people who are working on those missions will go find new jobs. And maybe they will end up at the Chinese Space Agency or the European Space Agency or whatever. And the institutional knowledge of all the people who worked on those projects will be lost to the ether. And even if some future administration really wants to bring those missions back, it's going to be brutally difficult to get them all started back up again. So, and I think right now, what are we? A month away from this finally happening. So that's where we are right now. KGS, all the visualization of the Oort cloud depicted as a spherical shell. Is it really a sphere or a more organically mangled, twisted shape? Yeah, so when you look on Wikipedia and stuff and you look at the Oort cloud, you get this sphere. And the reason, there's two reasons why we think it is spherish. One is because comets come from random directions, that we don't find that comets are tending to come down through the plane of the ecliptic, like where all of the planets, like if it was a torus around the solar system, then we would see comets coming in along the plane of the ecliptic where all of the planets and the sun, right, they're all lined up. We don't see that. We see them coming in randomly, higher and below and from top and so on. But there was a recent paper, I think we reported on this about 6 months ago, where researchers calculated the gravitational influence and found that there were probably kind of lobes of the Oort cloud. So some are kind of closer, are more like a horseshoe. And then as you get farther, it becomes more sphere-like. And the reason it becomes sphere-like is that the amount of gravity that these objects are experiencing right out the very edge of the Oort cloud, like you're almost 2 light years away from the sun at this point, that you're experiencing a negligible amount of gravity from the sun, and you're starting to experience all of this gravity from all of the other stars in the Milky Way. And that these objects are experiencing 3-body interactions with each other, that 2 Oort cloud objects will get relatively close to each other. They'll, change and tweak each other's orbits constantly, and you're just getting this shuffling. So maybe, the Oort cloud started out as a disk 4.5 billion years ago, but over time, all of the objects have just gravitationally interact with each other and just turned into this giant spherish field around the solar system. Christopher Kirby. My 4-year-old son, Faye, asks, why isn't there gravity in space? And talking about how astronauts are floating around on the space station. So there is gravity in space. And this is going to kind of blow your kid's mind, but you are experiencing the gravity of every single thing in the entire universe. Anything that is made of stuff makes gravity. That you are experiencing the gravity of the Earth, and that's what keeps you stuck on the surface of the Earth. But you're also experiencing the gravity from the moon, and that's why we have tides, right? The water goes up and the water goes down, and that's because of the influence of the gravity coming from the moon. We actually experience the gravity from the sun, and that's because when you have the tides, a little bit of the tides are caused by the sun. And in fact, you're experiencing the gravity from every single galaxy, every single star, everything in the whole universe. And here's the part that's crazy. When the astronauts are on board the International Space Station, they are a few 100 kilometers up from the surface of the Earth, and they are experiencing almost the same amount of gravity that you're experiencing down here on the surface of the Earth. And yet they are floating around in space. So why is that? Well, it's because they are falling. So think about when you throw a ball, right? And you throw the ball and the ball goes on this arc, flies up in the air, and then it comes back down and then it hits the ground. And when the ball reaches the top and it starts to come back down, it is falling. And if you were a little astronaut inside the ball, you would feel like you were floating around inside this ball. Well, the reality is that you're falling and you're about to hit the ground. And so imagine you could throw the ball even farther. You could throw the ball over the horizon. And eventually you can throw the ball so hard that it goes all the way around the Earth and lands, say, behind you. Or you throw it, you turn around, and you catch it. And so for most of that entire time that ball was going around the Earth, it was falling. It was feeling no gravity. That's what's happening on the space station. The space station is following an orbit around the Earth so fast that it is falling. And the feeling that the astronauts have on board the space station is not like what it would feel like to be like underwater when you're like swimming around. It feels exactly like when you're falling the whole time, always. And in the beginning, they get very sick. And they're like, and it's really hard for them to handle because it feels like you're on a roller coaster, or it feels like when you jump off a diving board into the water, or it feels like you're, when your dad throws you up in the air and then you fall back down into his arms. That feeling, that's the feeling that the astronauts are having while they're on board the space station. And it just goes on and on and on. And they can do this, right? The space station has been there for more than 25 years. Falling and falling and falling, and it can never hit the ground because it's going so fast sideways that it just keeps going. And so that's why they are experiencing gravity. If the space station stopped, they would feel like, and just hovered there in space, they would feel exactly the same gravity that you feel. It's because they're falling. La laddie la da da. Do I experience the gravity of the pillars of creation? And how? You experience the gravity from everything. And the pillars of creation are giant clouds of gas and dust in the Eagle Nebula caused by the enormous radiation pressure of hidden stars, newly forming stars that are blasting away material. That material has many times the mass of the sun. And you're experiencing its gravity because it is within the observable universe for you. Gravity moves at the speed of light. And so if you can see the light of a thing, you are also experiencing the gravity from it. Christopher Kirby, that was a great answer. Thank you. Yeah, I mean, obviously you're going to have to throw your kid up in the air a bunch of times, but you know. Badri Karacheri. How do radiators work in space? How are they able to get rid of heat? So on Earth, when you are trying to get rid of heat, we have three ways that you can do it. You have convection, which is where the air is moving heat away from you, right? When the wind is blowing on you, then it removes some of the heat and you cool down. You can have conduction, where you are touching something and the heat is moving away from you through that. So if you wear, I don't know, like a cold, if you or if you put on, like, you take a blanket out of the dryer, right, and you huddle under it, then you are conducting heat away from the blanket. Or when you when you touch a hot pan, right, is conduction. And then the last one is radiation, and this is where photons are being generated off of the surface of an object, and generally infrared heat, and they are zapping away into space, and that is a way. And so while you're sitting here, like I'm sitting here in my chair and I have convection, I have cooler air that is moving around and taking away heat from my body. I'm sitting on the chair. I can feel the coolness of the chair under me. And then also the radiation. If you get really close and you can feel the heat coming off of my skin. So it's the radiation is the thing that we're talking about here. And in space, there is no convection and there is no conduction. You're not touching anything and there's no air. So you can't get rid of heat that way. You can only get rid of the heat by radiation. And so the way you get rid of heat is you make radiators. You essentially want to make as much surface area as you can. The more surface area you have, the more places where the photons, can radiate away. And then they have a coolant that runs through the spacecraft and goes through the radiators and heats up the radiators. The radiators are radiating that heat away off into space, and then the liquid is cooled down and comes back through, and they use that to cool the rest of the spacecraft. And that, in fact, it's not about, in space, people think, well, it's really, really cold in space, and so you have to deal with keeping things warm. But when you're close to the Earth, when you're on the moon, it is not the cold that you have to deal with. It is the heat. It is the lack of radiation. And it is a challenge to try and keep yourself cool enough. When you look at the International Space Station, you see the solar panels, but then there's another set of things that are almost as big. They look like solar panels, but they're actually the radiators for the space station. Edward, what are the contingency plans if someone dies on the ISS? They have them. There is a medical book that is written for NASA, for the astronauts on board the International Space Station. And if there is a death on the station, then they have body bags on board the station to put someone into a body bag and put them into the capsule. One of the Progress or one of the Soyuz or the Dragon capsules attached to the station, and then they will bring the person down to Earth for a burial. This is covered in their policies and procedures. NASA has thought about this and considered it. You think about what would happen if astronauts went to Mars or went to, on the moon, they'd probably bring them back. Mars, they'd probably leave them there. So they would probably dig a grave and bury them on Mars. They put them in a photon torpedo tube. Yeah. What's that? Star Trek 2? Tim Onium, can you recommend a decent pair of binoculars? Why are they called a pair of binoculars? You only need one binocular. Yeah, I'm not sure why it's a pair of binoculars. That if it's a monocular, then you need a pair of binoculars. but it is a binocular. You just need one binocular. But the binoculars that I recommend for astronomy is there are special astronomical binoculars, and you want something that has both really good magnification and has really large apertures. So when you buy a pair of binoculars, there's two numbers. Generally, the binoculars that you all have are like a 7 by 35, which means that they have 7 magnification and 35 millimeter aperture. So the lenses on the front of it are 35 millimeters across, 3.5 centimeters. That's just like your regular pair of binoculars. You can get smaller ones that are like 8 by 20. So they're 20 millimeter, but they still have 8 magnification. But generally for astronomy, you want the biggest telescope you can get. And so they make special astronomical binoculars. The pair that I have is 15 by 75. So it's 15 magnification, 75. They're Celestron Skymasters, and they're not very expensive. Like, you can often get them for under $100. They make a bigger version as well. I think they make like a 25 by 100, and they're big and heavy. But better if you can hold them and not get really tired while you're looking at things. So, but any of the Skymasters are good. I would tend towards the 15 by 75s, but if you're willing to put them on a mount, you can go with the bigger versions and you can get a better view. But the other thing that I really love is the Canon makes a set of binoculars which are auto stabilizing. They're very expensive. They're more than $1,000. They're IS, image stabilization, and that you put a battery in it, and then it sort of modifies the optics inside the binoculars to keep the view steady. And so they work like regular binoculars, and then you press this button, and then the sky just stabilizes, and you don't get that shaking that you get when you're normal. Like, think about how your phone camera works now when you shoot video. They're amazing. Just amazing. They don't come as big magnification, but they're much more pleasurable to use because they're so stable. But yeah, so Canon image stabilizers or the Celestron Skymasters, but other people make them as well. And binoculars are great. They're a great first instrument to get. Like, if you're interested in space, we always recommend on Astronomy Cast that you start with binoculars because they really enhance your view. You can see the moons of Jupiter, you can see the rings of Saturn, you can see craters on the moon, you can see the Orion Nebula, you can see Andromeda. Like, you can see a lot of stuff with them. You can see globular clusters, open star clusters, nebulae, galaxies. Like, you can see, especially in good dark skies, they're kind of surprising how useful they are. Comets, and then you can use use them for birds. So they're relatively inexpensive, and they're easy to use. They're quick to use. They're easy to have on hand. The best telescope is the one that you have available to you. So yeah, I highly recommend binoculars. Like, if you're at all astro curious, buy a pair of binoculars. Scott Willis, how can elliptical galaxies have a supermassive black hole? I understand spiral, irregular, hoax galaxies, but wouldn't a supermassive black hole create a disk like the others? Are white holes a possibility? The white hole is a totally separate question. Well, so giant elliptical galaxies are the final form of galaxies, that you take two spiral galaxies and you collide them together, that the spiral structure is lost in the galaxy. Maybe you throw 3 of them together, that instead of you having this nice spiral that has remained mostly unblemished since the beginning of the universe, now you have this mess of this spiral galaxy came in this way and this one came this way, and boom, and now their stars are all zipping around, and it's like a giant beehive of stars. Well, this, the first galaxy had a supermassive black hole, and the second galaxy had a black hole, and when they collided, their black holes found their way to each other and then merged. And the largest, or think about the images taken of supermassive black holes by the Event Horizon Telescope. Right now, this worldwide network of telescopes is taking pictures of two supermassive black hole event horizons. One is the one at the heart of the Milky Way, and the other is M87, the giant supermassive black hole at the heart of the elliptical galaxy M87. And that's because it's gigantic, that it's the biggest, it's the, I guess the second biggest, or it is the biggest black hole event horizon in the sky that we can see from our perspective, because it is so big. Even though it is so far away, it is so big. And it has, not only does it have a supermassive black hole, but there's like a jet of material coming out of the supermassive black hole. So it is, and so just, when galaxies collide, the black holes have to go somewhere, and where they go is together into bigger black holes. Grave Spinner, have you watched the attempted launch of Nord Space? I haven't. Toner Low, any experience with using night vision equipment for stargazing? No, I haven't. I bought a pair of night vision binoculars for my wife as a birthday present one year, and they don't get used because they're not like looking through a pair of binoculars. They have like a little TV screen, a little LCD screen on them that converts the image, the infrared image that you're seeing, into something that your eyes can see. And it works. Like you can look through the binoculars and see a deer chewing on your garden in the middle of the night, but we just haven't found a lot of uses for it. But the great thing about astronomy is that the things that you want to look at are producing light. And so you don't need to look in other wavelengths, although, obviously astronomers want to, but just as long as you can magnify the light, then you're good to go. Okay, let's see. Sid Vicious, will you please continue to recommend small astronomy channels on YouTube? Any recommendations this week? I really enjoy providing recommendations to smaller astronomy channels. The problem is the AI slop problem, which is that it's really hard for me to discover new channels that are legitimate and that the person is like actually talking about science and space and astronomy. And like, obviously this is just me not being willing to put in the amount of work that it takes to find these hidden gems. And I'm so happy when I do. But it just takes time, and I have to sift through tons and tons of nonsense before I can find a channel. I'm like, oh wow, like this person is a legitimate space journalist and is reporting on really interesting news. And yeah, I found some incredible people. Like, it's kind of amazing when you look back at some of the people that I've recommended. A couple of hundred subscribers, and yet they're doing really good work, and I wish I could. So I thank you for the reminder. I will double down and keep trying to find good small astronomy channels, and I kind of just depend on you all to direct me. And it's funny because I'm like, can you please recommend some small astronomy channels? And people are like, Dr. Becky, PBS Space Time, Anton Petrov, right? Astrum. I'm like, no, smaller, not hundreds of thousands, not more than me, smaller, thousands, hundreds. Let's see dozens of subscribers. Then I'll be really happy. GR, are there any aliens? We have no evidence of aliens so far. Former Music, did you read my comment? I read your comment. I was just busy answering questions. Nitro, do black hole accretion disks look the same from any angle? No. In fact, there are different kinds of active galaxies based on the angle of the accretion disk around the supermassive black hole. So, and I see if I get this right. So when the galaxy is face on, or when the accretion disk is face on, and it's producing a jet straight down, and we're looking right down the jet, that is called a blazar. When it is a little off angle, but we can see the accretion disk, but the jet is not pointed directly at us, but it's still very bright, that is a quasar. And when we're seeing it edge on, where the actual supermassive black hole is hidden by this torus of gas and dust around the galaxy, that is a radio galaxy or a Seifert galaxy. And they're all just three versions of the same thing, just depending on the angle of where we see it. Do we see it face on? Do we see it at an angle? Or do we see it edge on? Former Music, are there gay aliens, though? If we have no evidence of aliens, how would we know if they're gay? Church discography, when's the red moon? Didn't it happen? Is it happening like tonight? Yesterday. Yeah, it happened last night. And we didn't see it in Canada. Asianometry channel, I've already recommended them in the past. Sid Vicious Anton, please put my question in the final edit. I'll pay you in crypto. Oh, you can't influence Anton that way. Richard Bacon, do you think that the private sector will fill in the gaps in NASA's budget with increased private spending? Absolutely not. No way. Absolutely not. I get this question all the time where people are like, it's fine that all of these missions are being cut, that the private industry will fill in the gaps and it'll all be great. Well, they won't. That no company is willing to spend money on a space telescope. No company is willing to spend money on a mission to study the ionosphere. Companies are willing to spend money on things that they think are going to make them more money. And basic science is not a thing that companies are willing to spend money on. Now, they might spend money on basic research if they think it's going to create new metamaterials that they can use, or if it's going to help them launch a worldwide network of internet satellites. But the kinds of science, the kinds of basic research that NASA does is of no interest at all to private industry. And so if and when NASA missions are shut down, they will just be shut down. That the things we used to know about the universe, we will no longer know. The questions that we have, we will not be able to get answers. And we'll have to wait for a new generation of scientists and governments and people to come forward and go, I'm curious about, whether or not there's life on Mars. I'm curious about how many black holes there are out there in the universe, and so on. And those kinds of, I'm curious about the concentrations of carbon dioxide in the atmosphere, the rate of glacier runoff, the acidification of the oceans, the weather patterns, all these questions, right? People are going to be like, is there a way that we could see hurricanes before they hit us? Yes, there's a way to do that. There was in the days of yore, I've heard legend that people launched spacecraft that did this kind of earth science. Well, someone should do that again. Rika, are we in a black hole? We have no evidence, no reason to believe that we're in a black hole. The inhibitors were from Revelation Space, right? Yeah. Okay. Man, this is an in the weeds question, but I'm here for it. Infinite Monkey, are the inhibitors a version of the dark forest hypothesis? All right, so I'm gonna nerd out on two sci-fi book series now. And so if you are familiar with the Revelation Space series by Alastair Reynolds, which I consider to be one of the greatest science fiction series ever written, it's easily in my top 5 favorite series of books, or the Three Body Problem Dark Forest series by Cixin Liu, then this answer will be interesting to you. But if you have no interest in those books, don't like science fiction, you might want to skip this one. But right, so and I don't want to be too much of a spoiler, but essentially in the Revelation Space series, the big bad, it turns out, spoiler alert, okay, you're being alerted to spoilers before you read the book. Now is a chance to dodge out. It's kind of like Mass Effect, that there are alien machines that have been waiting since the dawn of time, and whenever life forms get too out of control, they get squashed so that life doesn't go on to take over the entire universe. That early on in the universe, there were terrible, devastating wars by the various progenitor races, and they decided they wanted to stop that from ever happening again. And so they set up the inhibitors, and the inhibitors stop people, but the inhibitors have been malfunctioning, and so people have been able to last longer before they get squashed. And the books are all about eventually finding out and trying to avoid getting squashed. That's me trying not to spoil it too much. While the dark forest the dark forest hypothesis is that game theory demands that when you discover the presence of another advanced civilization in the universe, your best bet is to destroy them. That there is no good outcome, that you can, even if you try to talk with them, chances are, the risks are too great that they're going to try to destroy you. And so first strike is your best move, or hide and don't let anybody know that you exist. So no, they're very different. The inhibitors are very much like, if you've ever played the Mass Effect game, there's the Reapers, and the job of the Reapers is to, once again, life got too out of control, that civilizations got too power mad. You got empires, you got foundations, you got people running amok and causing so much harm and grief to one another that someone said, somebody's got to do something about this. And Thanos, right, is the same sort of version of that, is saying someone's got to stop this from running out of control every time. They deal with this actually in the Ian M. Banks culture series as well, where they have, and I forget the name of them, but essentially every now and then there's a robotic civilization tries to explode out and try to dominate, to Borg the galaxy, and so there are people who specialize in putting down sort of AI revolutions. And so, no, that's about somebody going, the only way to, if people aren't going to live in harmony with the universe, then we're going to force them to by culling them, right? If people can't understand, like, stop trying to turn everything into Comptronium, we're going to Thanos snap you back to your place. And that's what the inhibitors are about. And that's what the Reapers are about. And that's what Thanos is about. While the Dark Forest is a really kind of depressing, not like the inhibitors are not depressing and scary and so on, but it's this sort of very jaded, I think, view on us interacting with other intelligent civilizations, that the only outcome, the only thing that you can do is kill them. That's everything else is just you putting yourself at too much risk of destruction, that the only thing you should do is kill them. And I don't like that idea at all. And David Kipping did a great takedown of the Dark Forest, that, there's a wide list of possibility options that you could do. It doesn't, it's not just kill or be killed. So no, I think they are sort of two different concepts, both horrible, but two different concepts. Did I just write my college essay? In this essay, I am going to compare and contrast the inhibitors from Revelation Space with the Dark Forest hypothesis. Marco Popovic, how long are we going to be able to see CMB radiation? Will it disappear in one point, or is it going to be detectable forever? So the CMB will be detectable forever, but define detectable. So the wavelength of the cosmic microwave background is stretching out. And so back at the beginning of the universe, when the CMB was first released, it was like 3000 Kelvin. It was the surface of a red star. And then over time, the expansion of the universe has stretched out the wavelengths. And so here we are today, where it is 2.7 Kelvin. It is in the microwaves. And in the future, it'll go out into the radio waves. And then the wavelengths will be longer and longer radio waves. And eventually the wavelengths will be hundreds of meters, thousands of meters, light years long. But it'll still be there. And so some future civilization, 100 billion years from now, will build more and more powerful radio telescopes, and they'll realize that there is this background hum in the universe, and that it is evidence that the universe had a beginning. Like, that's the crazy part, is that if we do, like, eventually it just won't be practical, that you would have to expand the entire resources of your entire solar system to build a radio telescope capable of detecting the presence of the cosmic microwave background radiation. It's not a thing you would do. It would not occur to you to do that, but it's out there, and that there will come this time when we will look out into the cosmos, and it will seem never ending. It'll seem like it's eternal. It has always been here. And that we happen to live in this time in the evolution of the universe within the first, 100 billion years that the universe formed, that the evidence of its formation is there, that is not eternal, that it did start 13.8 billion years ago. And aren't we lucky to live in a time where all the possible times that we could have appeared in this universe, we appeared at a time when the history of the universe is knowable, which is kind of a weird thing to think about. Aaron Brinkroff, how sure are you that Planet 9 exists? I'm not sure at all. I am a reporter, so two very respected Scientists have done the math, looked at the motions of all of the objects in the outer solar system, and it seems that something is perturbing them. Something is pushing them around, pulling them around. And we've seen this before. This is how Uranus was discovered, that its gravitational influence on the outer planets was so great that astronomers were able to calculate where Uranus should be. And then they pointed a telescope in that place and they found it. And it's the same thing. So astronomers have calculated the motions of all of the objects in the outer solar system, and they've found that you can explain their motion, that there is something big out there that is perturbing their orbits. And now, but this thing is very dim and very far away and very hard to find. And so it's going to require, it's going to require luck or a very powerful telescope like Vera Rubin. Scott S. If a giant meteor were heading towards the Earth, would the governments tell us or try to suppress it for as long as possible? So if a giant meteor was heading towards the Earth, if there was an asteroid or a comet on a collision course with planet Earth, the governments would not be the place where you would hear about it. It would come from the astronomers themselves, that the people who are using the big telescopes and making discoveries, they announce their findings immediately to each other. They don't go through governments. That the discoverer of 3I Atlas, the discoverer of Oumuamua, the discoverer of Borisov, the discoverer of various large asteroids, Apophis, things that have been potentially dangerous in the past, that they are discovered. The one that was, oh man, see, I've even forgotten the name of that other 2025 YR4. How soon we forget? That when astronomers find an object, they announce it to the public immediately. They announce it, and then other astronomers will look over their work and confirm their observations and check to see whether or not they're right. And it's too late. Only governments can put that back in the bag. It's not like an astronomer every night does all their observations and takes everything that they've looked at and they bring it to the government and go, hello, government, here's what I looked at last night. Can you look through this and tell me if there's anything that you want redacted? It doesn't work that way. Astronomers are just people. They report and announce what they found to each other and to the public and to the press and to me, right? They call me and they tell me what they found, and then I report it. And the government had nothing to do with it. So, I think there is this hilariously wrong expectation that the government is involved in the potential suppression of information about the universe. Government has no role. The role of the government is they fund a telescope and then they get out of the way. And then they come back later if the telescope needs more funding. And that they write the checks to have these things built. Now, there are a few examples, like, say, the Department of Defense working with the Vera Rubin Observatory. They helped fund the telescope, and they are scrubbing out images of U.S. spy satellites from the images. Okay, right? But apart from that, there is no filter where a government could step in and say. So it's a moot point. It is a nonsensical question because astronomers would be arguing about the trajectory of this asteroid for months in advance. And if you ever watch Don't Look Up, they cover that. It's exactly that often it's not about people trying to cover up what it is that you found. It's that nobody will listen, right? You found something concerning and you're trying to let people know, and nobody cares. Nobody is paying attention or is arguing with you or trying to discredit you or trying to figure out some way to commercialize what it is that you found. And anyone who claims that the government is suppressing their science is not doing good science and is not is just not communicating and working with the system the way it has been developed and has been running for hundreds of years. John Riviera, why aren't there more asteroids outside of our solar system? There are probably an infinite number of asteroids outside the solar system. The problem is that we haven't seen any yet. Now, there are almost certainly interstellar asteroids passing through the solar system, as well as the interstellar comets, but asteroids tend to be closer in to the star system, and so they don't get kicked out as easily as comets. Comets are right at the very edge. They're just hanging on gravitationally, and so they're very easy to fall over the cliff and start drifting out into the Milky Way, while asteroids are bound a lot more tightly closer to the center of the star. So we're probably going to find a lot of comets before we find a single asteroid. Alicia's Mitchell, should the Voyager engineers get Nobel Prizes? I mean, I don't think it works that way, unfortunately. Be cool. Casey Ream, do they still monitor astronauts' vital signs, at least during launch, reentry, and spacewalks? I'm not sure how much they monitor their vitals these days, but the astronauts are regularly taking blood tests, regularly getting their blood pressure done, regularly doing urine samples, and they are experimenting on each other during their time on the space station. And then when they get back, they have to continue doing experiments because scientists want to know the effects of being in space on the human body. And so they're constantly giving blood samples and doing bone density scans and things like that. EKGs, finding out how their hearts work and so on, because we know that going to space is hard on the human body. The question is exactly how hard. Where is it? What are the parts of the body that we need to watch out for if a person is going to go to space? Church discography. What were you bridging on your property? So I have a bunch of little streams and ditches on the property, and constantly it's just a pain to cross over them. I have to go down into the ditch and up the other side. If I'm like, I can't take a wheelbarrow across it. And so a buddy of mine is a builder, and he's got a bunch of projects at his place. And so every Saturday he comes over to my house and we work on various building projects on my property. I've got a huge laundry list of projects that I want to work on. I want to build garden beds. I want to build a new compost. I'm going to build some, more bridges. I've got like 5 or 6 more bridges that I need to build to properly get out into the, into the property and be able to carry a wheelbarrow around. Bat boxes, bird boxes. I've got all of these things that I want to build. And then he's got a bunch of technology issues that he needs help with. And so I show up with him and help him organize his stuff and sell his stuff on Facebook and set up his all his various software for his company and stuff. So it's sort of, we have a good partnership back and forth. And I highly recommend it. Like, I feel like this is one of the greatest ideas that I've ever had, which is that we all have this mental checklist of projects that we want to work on, or we have shame of piles of junk that we need to get rid of, or skills that we want to learn, or activities that we want to get better at. And we just sit and feel stressed out about those things. And all you need to do is find a buddy, someone who has their own set of worries and concerns and unfinished projects and to-do lists that they need to do. And then one day you go over to their place and you just work through their to-do list, because you have no emotional baggage on their problem, right? Like, I'm helping my friend clean out a sea container that he hasn't been able to get into for 6 years because it's just, it's like a junk drawer the size of a sea container. And for the first time, like, we can get right to the very back of the thing, and he sold off half of the stuff in it. And you can see he's walking around with the weight of the world off his shoulders. And it just took us 2 Saturdays to make this huge dent in this problem that was causing him so much grief. And so, yeah, it's like, and so I don't care. Like I show up and we just like, are we going to sell this stuff? That sounds great. Are we going to move this stuff over there? That sounds great to me. I don't care because I'm going to get a bridge. Next week, you come over to my place. We're building a bridge that I really need. And I don't know where to start because I'm not that kind of guy. And so, yeah, I highly recommend. Like I said, I feel like it is the greatest idea that I've ever had. You've seen me do live telescope streaming and Universe Today and all this stuff. No, the greatest idea that I've ever had is partnering with my buddy to wrap up each other's to-do lists. Where are we at? Whoa, 4 minutes to go. Nate S., is there any way that we can get more ways to sort old articles? Yeah, the site nav architecture is terrible. The navigation on the Universe Today site is really bad, and we will fix it. It's on my to-do list. And my friend can't help me with that. Show the bridge. Yeah, I don't have the picture handy. It's like 16, see, what is it? It's about 5 meters long, a meter wide, has a bit of an arch, has 2x6s on the top, and you can just go over it. And then we've got two more. One is like 4 meters long, and then one is 3 meters long. And then I've got a big one that we have to build that's going to be about 8 meters long that we're trying to figure out a good way to do it. Andrew Durs Williamson, do we live in a black hole? There's no reason to believe that we live in a black hole, but some people have proposed it and nobody has confirmed it one way or the other. So it's a hypothesis, but other people think it's ridiculous. I'll put a picture of the bridge. I'll put a picture of the bridges up in the on the Patreon this week. Todd Ablett, would a set of 25 by 70 binoculars still be good for beginning sky gazer? Absolutely. Those are great. Robert Nicola, why haven't they found any meteorites older than 4.6 billion years old? Because that's when the solar system formed. And so nobody has found any meteorites that have come from before the solar system. They have found pre-solar grains mixed in with meteorites. So little bits of and pieces that were there a little like several hundred million years or billion years before. But the actual meteorites, they all come from the solar system and everything formed at the same time. It'd be amazing. Those bridges sound illegal. Yeah, they would not. I mean, one of the bridges is maybe a meter off the ground and would not pass inspection. But that's fine. Shh. Are we at the end? Yeah. All right. We've reached the end of this week's inaugural question show for the new season. So thank you, everybody, for hanging out this week. Thank you to the moderators who showed up. I see Arjun is here. I know Zappan was here. So cool to be back. I missed this. Like I take the break because I am tired and I do need to sort of think again, but I really look forward to coming back. And I was like thinking about it today. I'm like, oh, what kind of questions am I going to be getting? Sort of thinking through it in advance. So it's so great to come back and do this again. What's coming up? We recorded the new episode of Astronomy Cast earlier today, so that's back as well. Apart from that, I got cool new interviews that I'm lining up. More Space Bites coming up. So lots of good stuff in this new season, as well as a bunch of collaborations that I mentioned. So we're gonna rank everything. All right, thanks everyone, and we will see all of you next week.